In previous videos, we looked at how we can compare population means from two different populations when we have independent sampling and large samples, but we never looked at how we can do the same kind of calculation for population proportions. So in this video, we're going to explore how to do that. And first, we're going to cover some basic properties of the distribution of our P1 minus P2 values. So our population proportion for each of those and the difference between those. So our properties for that, we have three of those. And the first is that the expected value of our P1 hat minus our P2 hat. So the sample proportions from both of our samples from the different populations is equal to our P1 value minus P2 value. So this is the same thing that we get for when we're doing it for the means. Our second property, property 2, so property 1. Property 2 is that our standard deviation for this, so sigma sub P1 hat minus P2 hat, is equal to, we have P1 times Q1 over N1 plus P2 times Q2 over N2, and we take the square root of all of that to get our new standard deviation. The third property is that if we're looking at these two population or sample proportions, that if we have a large sample, that sample is normally distributed when we're comparing the two. And the last thing that we're going to cover for this small piece is that what we're going to consider for a large sample. So we're going to consider it large if for each of our i's, or each of our p's, so pi times ni, is greater than 15, greater than or equal to 15, and that qi times ni is also greater than or equal to 15. So we would do this for both of them, so we need it to be large for both. So P1 times N1 is greater than 15, P2 times N2 is greater than 15, and the same for our Q's. And now we're going to cover how we can actually calculate the confidence intervals. So we're going to do confidence intervals for our large sample proportions. And since we know this is normally distributed, our confidence interval shouldn't be too much of a surprise. We're going to say our confidence interval is P1 hat minus P2 hat plus or minus, and we're going to use our z sub alpha over 2, z of alpha over 2, times our new standard deviation, so sigma sub P1 hat minus P2 hat. And if we substitute in for our standard deviation, we get our P1 hat minus P2 hat plus or minus z of alpha over 2 times this value up here, or the square root of P1 Q1 over N1 plus P2 Q2 over N2. And that's how we calculate our confidence interval. However, since we don't have the actual values for P1 and Q1 and P2 and Q2, we need to substitute in our calculated values for that. So P1 hat times Q1 hat over N1 plus P2 hat times Q2 hat over N2. The final piece that we're going to look at is how to do a hypothesis test for this. So we're going to do HT for our hypothesis test. And the null hypothesis for this is all going to be the same. So we're going to do H naught is equal to our P1 minus Q1. We're going to say that is equal to some D naught value. And most of the time we're going to set that equal to 0. And then for our alternative hypothesis, we have our HA. We're going to do P1 minus Q1, and we can have our greater than, not equal to, or less than for our D naught value. And again, we're normally can set that to 0 because we're normally going to be comparing to see if the population proportions are the same or different. And then for our test statistic for this, we're just going to use our z value. So we're going to do z is equal to our P1 hat minus P2 hat, P2 hat, all that minus our D0, which again is normally going to be 0, and divide that by our sigma sub P1 hat minus P2 hat. And again, this sigma down here is the same as our sigma up here, and the same one that we've substituted in before. So if we need to calculate sigma, we would substitute in the hats instead of just the standard P1, Q1, P2, Q2. We would do P1 hat, Q1 hat, P2 hat, Q2 hat. And then we just calculate that out, and we can do the same standard hypothesis test that we would normally do, and there should be no significant surprises as we walk through these various calculations.